All right. My name is John Harvey. You may know me from such things as your class. Today, I'm going to go over the whys and wherefores of the straight line Z-D diagram. Pardon me. Like many of you, I have my own whiteboard at home, and so we'll be working with that. Now, some background. Do you remember in high school when you did algebra or whatever, the intercept is A and the slope is B. So, for example, which by the way is delta y over delta x, right? So that's going to be the intercept, and that's going to be how much y is going to change because of a change in x. For example, let's say that A is equal to 5 and that's equal to 0.5. Now what that means, of course, is that for every 1 unit x changes, y is going to change by a half a unit. So, check this out. My scale's not going to be exactly right, but you get the idea. Let's see, I don't know, 20. As you can see, the scale's way off, but still. So if this is 20, and since x, for every 1 unit change in x, y changes half a unit, so y must have gone up by 10, plus we were already 5 off the ground to start with. That's 15. And to double check that, let's write out the equation. Y is equal to 5 plus 0.5x, right? So then you plug in 20 for x, 5 plus 10, 15. Very exciting. So, with that as a reminder, let me show you how the Z-D diagram thing works, because it's really not that complicated, especially the D curve. The Z curve takes just a second to think about, but here we go. I used to use this to clean my car, but now I don't. And the board is leaning up against, as you can see, the blinds, which is what makes all the noise. In experimenting with the various pens to see which ones were most visible, I found that unfortunately the black one is the only one that really works well. So I don't get, well, I may try some multicolored stuff here in a minute, but the tuition you pay at TCU certainly entitles you to more than one color. Now, let's see, I'm going to do the same thing again. Well, let me back up here just a second, just go back to the algebra again, right? So remember, remember what it's all about in general. That's what we're trying to figure out. Why? We don't know what y is. We're trying to figure it out. Oops. And x is what we're given. Of course, we're also given a and b, but a and b don't change. A and b are always the same number. X will be given a variety of values for. So, but once again, very important, what we're trying to figure out and what we're given to help us figure out that value. All right, now back to John Maynard. Oops, terrible Y, right, PY. Let's do the demand curve first. There's the D curve. Now the equation for the D curve, let's see, how far back, I'll lean back for a second. The equation for the D curve is, oh, what letters did I use? Well, beta plus lambda n. Okay, beta plus lambda n. First of all, let me just write them on there. Beta and lambda. Of course, n's already there. Now, the idea of this one is to figure out what is total demand. This is what is actual spending, not the expected one that you have off of the Z-curve. This is actual spending. So, the idea is, I wonder how much firms and households actually spend during the period in question, and that's this number right here. That's how much they did actually spend in a given period. So, just like with the y and x axes, this is what we're trying to figure out. This is the one we're trying to figure out, and we're trying to figure out, given this, given a particular level of employment, what ends up being total spending. And what total spending ends up being is the intercept. Let me see if you can see that. Yeah, pretty much. The intercept, which could be any one of the injections, but we're narrowing it down to investment right now. So how much was spent by firms and consumers in total in the macroeconomy? We have no government, we have no foreigners, so that's all there are. How much was spent by firms and consumers? Well, for investment, this number right here. And essentially, that's going to be consumption right there, all right? And what's consumption going to do? So we've got investment here and consumption there. What's consumption going to do as we move to the right here? Well, more people have jobs. And for simplicity, we're assuming they all have the same wage. So, you know, if we double this down here, then we've doubled wages. If we have it, then we've had wages and so forth. So, once again, what we're trying to figure out, what we're given in order to figure it out. And let's see. I think I'll plug some numbers in. What have I got here in my notes? Yeah. Let me redraw the whole thing. And then I'll try plugging some numbers in. This is Melanie's office. If you can see around, it's very nice. She never uses it, so I get to use it. All right, let's see. Ooh, that's not as good as the other one I was using. I'll throw it over there. There we go. What we're given, what we're trying to figure out. There's a particular D curve. Now I'm going to write the equation again over here. What we're trying to figure out is equal to beta plus lambda n. Beta plus lambda n. All right. Let's see. Let's make B equal to, what did I use in my example here? I used 50. 50. So investment is going to be 50. Now notice that regardless of how much n is, investment's always going to be 50. Now, next thing is, let's say I'm going to make up a slope. What did I make up last time? I made up 100. Clearly, that does not have a slope of 100, but pretend. Right? So we have lambda is equal to 100. So essentially, for every increase of 1 unit on n, py is going to go up by 100. Because remember what this lambda here is, it's the change in this divided by the change in that. So for every 1 unit increase down here, there's going to be a 100 unit increase over here. So let's just pick a value. What I pick here in my example, I picked 5. Actually, the slope could be okay if the two axes are scaled differently, but no, they're not. Watch what happens next. Okay, so what have I got? I've got py is equal to, oh, can you see the orange one? Py is equal to 50 plus 100 times 5. I wonder what that is. 550, right? So this much of it was the 50, which was investment, or beta, and this much of it was 500, which was essentially the consumption. Yeah, essentially the consumption right there. And once again, the lambda was the change in this variable divided by the change in that variable. Therefore, for every 1 unit change here, in this particular example, well, for every 1 unit change here, this goes up by lambda, which in this case was 100. I think that's it for that. Let me see what else I got written down here. Yeah, see, that one is by far the easier one of the two because it is just exactly like the y and x thing. The problem, of course, is the Z-curve, but it's not that big a problem if you break it down carefully. All right, so what we got so far, what will actual spending be in the macroeconomy given a particular level of N? We're going to take as exogenous for now. The next thing we're going to do in class is talk about what does determine investment, but take it as exogenous right now. And so you can see that as N goes up, then the consumption part goes up, so the total spending goes up. Now, how many workers will firms hire? I cannot tell you how long it took to get a camera that worked, the sound that worked, and a screen that would stay up. I do have, this is the, oh, I see what happened. I keep leaning against this weight over here and pushing the whole board this way. All right, well, I'm sure that was amusing. Now, Z-curve. Oh, it's a terrible Z, sorry. Alpha, right? Okay, very simple concept. How many workers will firms in the macroeconomy hire? It will be a function of how many, what they expect sales to be. If they expect sales to be 0, then there's no intercept, because if they expect sales to be 0, the speakers that I have on for watching TV in here are crackling. Oh, they stopped, okay. That whatever lambda is, for every $1 increase in expected sales, they'll hire that many more workers. There's no intercept because you don't hire anybody if you don't expect sales. You put a 0 there, you get a 0 there. Now, check this out. We're done with that page. And I'm going to put the E on there to indicate expected. Herein lies the problem with this one, and that is, on the Z-curve, this is what we're trying to figure out, and this is what we're given. So we flip the axes, all right? The variable that is independent, that we are given, is now here, and the variable that is dependent is now down here. And we are used to writing this, well, the usual way of writing the equation for this line is, of course, y equals a plus bx, where y is the vertical axis and x is the horizontal axis. Well, let's do that again, all right? Let's just rearrange this. In other words, let's rearrange this equation so it's set up the same way the demand curve equation is, which I'll jot down up here. Let's make them both py equals. That way we've got them both in the same terms. Expected sales equal to 1 over n. Now remember, what makes this hard to think about here, of course, is this is actually the variable we're trying to figure out, and we're given this one. But if we want to write these two in a way that's directly comparable, we have to rearrange this one. Hence, you've got your intercept of 0 down there, you know, that we could have written PYE is equal to, I don't know, gamma plus whatever, but gamma would always be 0, so it doesn't matter. And the slope here is equal to 1 over, 1 over that variable right there, because it's the inverse. You can see right here, when you rearranged it and put it in the same terms as we had the other equation, now it's 1 over alpha. Let's see, do I do an example next? Yeah. If you put a couple of numbers in here and show it both ways, then you can kind of see what's going on. Let's see, let's do it this way first, all right? Let's do it, I'm going to change colors here. See how the green looks when I try that. Oh yeah, that's not too bad. Yeah, I got a TV right there. Let's see, let's make something up for this alpha right there. Let's make alpha equal to, what did John Harvey do the first time? 0.01, okay. So in other words, for every $1 increase in sales, if you look back at this equation up here, for every $1 increase in expected sales, firms will hire 1/100th more of a worker. Or in other words, it's going to take $100 worth of sales to hire one more person, right? So let's say that that's our formula right there. N is equal to 0.01 PYE. Now, if we want to change this into this form over here, then okay, let's solve it for PYE instead. All right, or 1 over 0.01 or 100. So now we've got the slope of this line. The slope of this line must be 100, all right, because we've got it in this, use another color. Now that we've rearranged it to this form, we say, oh, okay, so what we're going to end up with is that for every 1 unit change in N, PY changes by 100. Now, let me say that again, because our slope here is, in this particular example, if we're going to use 0.01 as the alpha right here in the equation that says, how many workers are you going to hire? Well, I don't know. What are my sales? And for every $1 increase in expected sales, the firms will hire 1/100th of an extra worker. Well, what does that show over here? How does that translate to this? Well, for every 100 unit increase here, there's only going to be a 1 unit increase right there, right? Now, the line of causation is going to be from here to here. What do we get here when we change something here? So that's reverse of the way we usually do it. But if we're going to take the slope straight up, the way this equation implies right here, it's going to be 100. It's not going to be 0.01, it's going to be 100. Because of the fact that, as you can see, for every $100 increase in expected sales, there'll be a 1 unit increase in employment. I'm going to do that one more time. Now, this is the straight up equation for how many workers will firms hire, and that's the logical, simple way to think about it. Because our dependent variable is, how many people are you going to hire? Well, I don't know. What are my expected sales going to be? Okay, well, in this example, for every $1 increase in expected sales, I'll hire 0.01 more workers. Okay, so that's their formula. And that translates into, well, basically, I'm not going to hire anybody else unless I got $100 more of sales, right? So now if you rearrange that equation so we can put it on in these terms right here, you end up with PYE equals 100 times N. Just exactly what we said. That for every time N goes up by 1, it must have been because expected sales went up by 100. Because notice here that if N is, hey, that's a good idea, John. Thank you, John. If N is 5, would have been a better idea if I'd written 500 clearly. $500 in expected sales translates into 5 employees, or 5 million, whatever our unit is. So this right here, the slope being 100, makes perfect sense because what we're getting is the inverse of how many workers extra you're going to hire for every extra dollar's worth of sales. And once again, the problem is we flip the axes. This became the independent, this became the dependent. So when we expressed it backwards. But when we change it into form that is directly comparable to this that we could put on this graph, we had to rearrange it like so. Okay, let's see what else I got here. I've done that. Oh, yeah. Okay, so here's the last thing I want to show you. It'll only take about 2 hours. Actually, it better not because I'm really hungry. All right, here we go. What I want to do now is show you those 3 equations. And I'm not going to go through the whole thing of solving it, but I want to show you the 3 equations and then show you what you get when you do solve it. And then I want to talk about why is that even worth doing. Let's see here. We got N equal to alpha times PYE. We've got PY equal to beta plus lambda times N. And don't forget, I made this whole freaking thing up, right? So if you don't use alpha, if you use the letter Z, that's fine, but just be consistent through the whole thing. If you use Z there, use it everywhere else. But if you don't remember this particular Greek letter on the exam, doesn't matter. You probably ought to remember the n and the py because those go on the graph. But these parameters here, I just made it up anyway. And then in equilibrium, the only point at which firms don't want to change their plans is when their actual sales are equal to their expected sales. Otherwise, we're not in equilibrium. Otherwise, they either sold less than they expected to, so they're going to lay off workers, or they had more orders than they had produced output, so they're going to hire more workers. Now, when you solve this equation for n, what you get is 1 minus alpha lambda. Yeah, that's it. Now, one may wonder, what the heck is that? Well, let's be reminded of what each of these variables is. Alpha was the number of workers, I'm going to have to stand up. Number of workers hired, yeah. Per dollar of expected sales. Number of workers hired, can you see that? Yeah. No, pardon me. Number of workers hired per dollar of expected sales, all right? So, like I did with the example a minute ago, when, what did I do? 500, and that was, 0.01 rather, and that was 5. So, how many workers are you going to hire per dollar of expected sales? That's what alpha was right there. What was beta? Well, in our example, let's just make it simple. It's just investment. It could also be exports and government spending, but it's just investment in this example. And then last, and by the way, this is a very handy tip here in math class. If you do that, it means kind of equal to, and I'm not sure they can take any points off whatsoever. If you, well, I said it was kind of equal to that. But it's kind of equal to the propensity to consume. It is most certainly a function of it, right? The idea is this, that as employment goes up, so incomes go up, and therefore spending goes up. Well, by how much? By lambda, right? So lambda is how much spending is going up as employment increases. So it's kind of like the propensity to consume. Now, let's look back at this equation here and think about what each of these things implies. And it turns out to be fairly straightforward, I think. It says that if firms are willing to hire more workers per dollar of expected sales, employment goes up. Check that out. If this goes up, that goes up. Ignore that for just a second. We'll get to it in a second. If this goes up, then the whole fraction goes up. Well, let's include it anyway. If this goes up, the denominator gets smaller. So if this goes up, if alpha rises, then the numerator gets larger and the denominator gets smaller, just so long as it doesn't become equal to 1 or larger than 1, which we'll talk about in just a second. So, when alpha rises, when the number of workers a firm would be willing to hire per dollar of sales goes up, employment goes up, exactly as we would expect. Then, what about investment? What if investment rises? Well, it makes the numerator bigger, right? So employment goes up. I mean, the advantage is we can plug in some numbers now. We don't just have a point on a graph. And we can also talk about the relative parameters. How realistic is it that, firms would double how many workers they would hire per dollar of sales? Extremely unrealistic. How likely is it that investment would double? That can happen, all right? So then you would say, well, then beta kind of is more important than alpha if we think about real world magnitudes. And then the last variable is the propensity to consume. So from the multiplier effect, you know that as the propensity to consume goes up, the multiplier goes up. And just as one would expect, if alpha gets larger, so the denominator gets smaller, and employment goes up. Why? Because total spending would have gone up. So, hey, I didn't think of this till just now. This one and this one are both related to actual spending. And of course, because they were up here in the actual spending equation. And then, let's see here, I shall use green. Those two are related to, well, I guess I could just say the z-curve, right? I could have just said the d curve here. And again, the equation says exactly what we would expect. And now, by the way, in the real world, alpha is not going to change much. That's going to be that, let's see, how many workers will you hire per dollar of expected sales? That's not going to change a lot very rapidly. It may over time. And likewise, the propensity to consume, lambda, is not going to change very often. So guess what that boils everything down to? Beta. investment. That ends up being the big factor if we want to think about how these numbers vary in the real world, the big factor in terms of fluctuations in N, and that's why the next study questions are about investment, because investment does turn out to be the key. Okay, one last thing here. I just said that a minute ago. All right, sorry. They have to hurry because Melanie and Alex are coming home, and usually when they hit the door, they start screaming and knocking over furniture and stuff like that. You won't be able to hear me anymore. Okay, what I want to show you now is all about that denominator. Let me write that N equals, let's see, don't tell me. I'm going to try to just remember. Oh, this is beta. And this one was, I'm not looking. This one was with the propensity to consume down here, and that, and that. I don't remember. I don't use the word genius too often. But yeah, that is the equation. Although I did have the two, it obviously makes no difference, but to be consistent with what I had already written, let's make that alpha lambda. All right, so there's the solution to the equation. Now, remember the last thing we talked about was that it's critical that that not be 1 or greater than 1. Otherwise, if it's equal to 1, then the denominator is 0, and we have no solution. If it's greater than 1, then our answer is negative. Well, actually, that makes sense if you look at the graph, right? And let's think first about what if that was equal to 1. What does that imply on the graph? And what it implies on the graph is that the lines are parallel. Like this. Now, let's see. I think I'll write the equations out over here. That's a drawback to having just made this stuff up. I can't remember what I wrote. Okay, yeah, I think that's right. Yeah. And then the z curve, we've got n equals that, but let's rearrange it. Yeah, there we go. All right. We'll call that equation 1, equation 2, and equation 2 prime. All right. Now, if those two lines are parallel, then we know this for sure. They have the same slope, right? So let's make up a number. Slope equals, I don't know. What did I use here in my example? I used 5? Yeah, I used 5. Okay. Slope equals 5, slope equals 5, all right? Now, when we try to figure out alpha times lambda, let's see, how much is lambda? Well, that's easy, it's 5. Lambda is the slope of the demand curve, it's 5. So, right there, all set. And what is the slope of z? Well, the slope of z is 5, right? Which is going to be this number right here. Therefore, so that's 5, and that's 5. But if that's 5, then alpha itself must be 1 over 5. Alpha itself must be 1 over 5. Because remember, the slope of the z-curve is 1 over alpha. It is not alpha, it is 1 over alpha. You can go back to whatever point of this video to see why the slope is 1 over alpha. So in that, because remember, I'm sorry, I just tell you this way. Because remember, in 1 and 2 prime, those are the ones that are directly comparable. All right? So that means that this is equal to 5 and that's equal to 5. But if this is equal to 5, we've got 5 there. But if this is equal to 5, if 1 over alpha is equal to 5, then alpha itself must be 1 over 5. And I got my calculator out earlier. Turns out that's equal to 1. All right? So, if the lines are parallel, you get 1 minus 1, you get 0, and you get this strange result. Oh, there is no definitive level of employment. And that's right, because the two lines are parallel. That notice what's going to happen here is that firms are continuously, let's see, let's put it this way, the simple way, because I could actually have the demand curve underneath too. Firms never sell what they expected, so they never reach an equilibrium level of employment. If there is no intersection, Firms never sell what they expected, and there is no equilibrium point. So that's what happens when they're parallel. If the demand curve is above Z, then they always sell more than they expected. The demand curve could theoretically be below Z. It couldn't realistically be. But in that case, they would always sell less than they expected, and they'd be shooting downward. And this one, they'd be shooting upward. They'd continually be correcting, hiring more people, but never reaching an equilibrium, which is why it ends up being over zero. There is no solution. All right. I swear this is the last thing. Let's see, what should I erase? I'll erase the whole thing. Well, except the equation at the top. The very last thing is, what does it mean when this is greater than 1, so that we have a negative solution to the problem? Well, I'll tell you. Let's go ahead and do that same thing with equations 1, 2, and 2 prime, because that's going to make things easy. Py equals, don't tell me, beta plus lambda n. And this is n equals alpha times py expected. And therefore, py expected is equal to 1 over alpha n. Okay. Now, if you end up with a negative solution, it's going to be because the demand curve is actually steeper than the supply curve in this way. There's the Z curve. Now remember, the demand curve is going to have a positive intercept. Investment is going to, well, logically it's going to be some positive number. Let's see here. Aha! We have a solution for n, but it's a negative number. Now, how does that translate into the equations? I'm glad I asked that question. Let's say that this slope, let's see, what example did I use before? Okay, I left the Z curve at 5. Well, let's say the slope of this is equal to 6, all right? Then what happens when we multiply out alpha times lambda? Well, I'll show you. Lambda clearly is going to be 6. Remember, these two equations here, let me use red. These two equations here are expressed in the same way, so we can compare them directly, and we can compare them on this graph over here. So if the slope of the D curve, and remember this is the D curve, and that's the Z curve. If the slope of the D curve is 6, well then lambda is 6, right? So lambda times alpha, I got a 6 right there. Can you see that? Yeah. I got a 6 right there. So what's alpha? Well, alpha's 1 over 5, right? Because if this is equal to 5, then remember this is the slope. The slope is 1 over alpha, so therefore alpha must be 1 over 5. And 6 over 5 is greater than 1. And so since 6 over 5 is greater than 1, we'll have a negative denominator, and the numerator is going to be positive because the alpha is always going to be positive and the beta is always going to be positive. So the overall number will be negative, and so the solution will be that firms would hire a negative number of people. Not lay off some people, but hire a negative number of people. I guess zombies or something like that. So, and that's it. I'd like to thank you for tuning in today in our first episode. I'd like you to also remember the 2011 Rose Bowl. I can never remember what year it was. That I was too horrified to watch. I checked I walked by the TV every now and then. I did see the last play. It's very exciting. And I guess that's it. May the force be with you.